All right, greetings. Today we are going to be covering how to solve equations, but we're going to solve equations that have variables on both sides of the equal sign. On the left there's going to be a variable, and on the right there's going to be a variable. So it's going to be something like this. So we've solved equations that has 12n plus 17 equals 21. But what if it's 12n plus 17 equals 8n plus 21, and you have n's on both sides? Well, you know that the goal when you're trying to solve an equation is to get n by itself so that we know what n equals. But in this case, we have to ask the question, which n are we going to try to get by itself? Are we going to try to get this one by itself? Or are we going to try to get this one by itself? So you can see that when there's variables on both sides of an equation. So let's actually tackle one. We're going to start with this equation right here. 5x minus 10 equals 13x plus 40. And we're going to ask the question, should I do 5x minus 5x? Or should I do 13x minus 13x? So how do we decide which one to do? Well, the official way is to pick whichever one is smaller. So in this case, we would do 5x minus 5x, and we would subtract 5x from both sides. But if you don't remember the official way to do it, it's okay to just pick one of the two ways to do it, and then see what happens, and then just make sure you check your answer at the end by plugging in your solution to the original equation. So we're going to do the 5x minus 5x, okay? Because if we subtracted 13x from both sides, we would get a negative number. And we like positive numbers better, right? Yeah, I think so. Okay, so let's get rid of all this other stuff, and let's just see what would happen if I really did do minus 13x on both sides. If I did minus 13x on both sides, this part would cancel out, which was nice, right? I just have 40 over here. But over here, I would get negative 8x. Now, that's not the end of the world. We could solve this equation, right? But it's easier to solve equations when you don't have a negative number in front of the x. Now, we can still do this, and we'd get negative 8x equals 50, and x is going to equal whatever 50 divided by negative 8 is, right? So what I want you to see here is we shouldn't subtract 13x from both sides because it gave us a negative x, even though we can do it that way and it'll still give us a good solution. It's better, okay, to not have a negative over there. So the better choice would be to do 5x minus 5x and 13x minus 5x. Because if we did it that way, we would cancel those x's out and we'd still have a positive over here. So let's see what that looks like. Let's cancel these out. 5x minus 5x cancels out. I have negative 10 over here, right? And then 13x minus 5x is going to come out to a positive 8x. And then I'm just going to bring down my plus 40. And now I can just solve the rest of this the way that I've always solved two-step equations. 40 minus 40 cancels, so I only have 8x left over here. And then negative 10 minus 40 is negative 50. And notice on this problem, our solution for x is going to be 50 divided by 8 again, but it's going to be negative. So we still got the same solution. So I guess the moral of the story is we want this part right here to come out positive, but even if it doesn't, everything's still going to be cool. All right, so if I gave you this equation, what would be the easier first step? We could subtract, we could subtract 3x from both sides, right? Or we could subtract 17x from both sides. Which one would be better? Well, I think it would be better to subtract 3x from both sides, because then when you finish this problem, these cancel out, and you'll have an easier, more simple equation to solve with no negatives in there. Does that make sense? Hopefully. I think you probably know how to solve the rest of that equation, right? So, what we're just dealing with here is the basic idea of making sure that you do the first step first. Okay, how about this one? Which one would you do first? We could do minus 5x, or on this one, we could do plus 6x and plus 6x. And notice that on this one, that's actually the better move, because this negative 6x and positive 6x cancel out because of that negative that was right here. Okay, it's actually better to get rid of the minus 6x by doing a plus 6x, so that now we have 11x, and it's a nice positive number, and we can solve the rest of our equation. Just for fun, let's go ahead and solve the rest of it. Minus 3, these cancel out. You have 11x equals 15 minus 3, which is 12. And so in this case, I'm going to divide by 11, this will cancel out, and I'll have x equals 12 divided by 11. You could do 12 divided by 11 on your calculator and give a decimal, or could we just say that 11 goes into 12 once with one 11 left over? Yeah, that is my solution. All right, so let's just do one more example problem, and I think we'll be good to go. I'm going to do this one fast, so see if you can follow along with me really fast. What's bigger, 12n or 8n? 12n is bigger, so I'm going to get rid of the smaller one. I'm going to do minus 8n. This 8n and this 8n are going to cancel out, leaving only 21 over here on the right side. 12n minus 8n is a positive 4n. And then I'm going to bring the 17 down. And then I'm going to get rid of the I'm going to get rid of the 17 first, because I get rid of the thing that's not attached to the variable. And I'm going to do that, and I'm going to put 4n equals 21 minus 4. And then I just have to divide both sides by 4, and I get n equals 4 divided by 4, which is 1. And I just solved that equation. Except, you know what? I shouldn't have circled that equation. At the bottom, n equals 1. Why shouldn't I have circled that solution? Because I'm not 100% sure that it actually is true. Does n equal 1? I don't know. I have to see if n equals 1 when I put that right in here. So, what's 12 times 1? 12. What's 12 plus 17? 29. Okay, well what's 8 times 1? 8. Plus 21, does that come out to 29? Does that work? Yep. Okay, so we're good to go. Alright, I think at this point you're ready to try this yourself, so here's one for you. And then here's another. Try to see if you can solve both of those equations that both have variables on both sides. And if you can, then you're all set. Thanks for watching. Thanks for listening. If you have any questions, ask me tomorrow.